This video is intended to describe the 17-mile tributary alternatives evaluated as part of the alternatives analysis for the Cherry Creek Minor Tributaries Major Drainageway Plan. For a detailed definition of the three alternatives evaluated throughout the Cherry Creek tributaries and the additional items considered, please refer to the alternatives analysis intro video on the About page. The 17-mile tributary basin is a smaller basin that is mostly undeveloped. However, proposed upstream development is anticipated to increase the frequency of events and affect the hydraulic regime of the reach, creating instability in the system. The alternatives analyzed for this tributary are as follows. The status quo or do nothing alternative. A flood hazard area delineation was not completed for the 17-mile tributary due to its relatively small contributing basin size. However, no insurable structures are anticipated to be inundated during the 100-year event. Only channel instability and erosion issues are anticipated. As such, the status quo alternative was evaluated to determine the costs associated with addressing erosion issues in the tributary and ongoing maintenance of the study reach. Alternative 1, floodplain preservation, mitigation, and management. To preserve the existing 17-mile tributary floodplain in the reach of interest, a permanent drainage easement approximately 7 acres in size is anticipated to be required to contain the 100-year floodplain through the 17-mile house property. Alternative 2, conveyance improvements. To reduce flood risk and potential erosional issues in the 17-mile tributary study reach, conveyance improvements are required. The proposed conveyance improvements include a high-functioning, low-maintenance process channel in combination with one access road culvert crossing designed to convey the 100-year event. The proposed channel has a stable slope of approximately 1.1%, 1.5 feet of freeboard in the channel between the 100-year water surface elevation and the surrounding terrain, and 8 2-foot grade control structures required to maintain the stable slope. The culvert is designed to convey the 100-year event with 1 foot of freeboard and satisfy the maximum headwater to depth criteria of 1.5. The 100-year culvert outlet velocity is greater than that permissible in the proposed channel. Therefore, the culvert will require energy dissipation at its outlet to reduce outlet velocities and shear stresses to those permissible in the channel. It is assumed that a grade control structure can be placed such that it functions as both grade control and energy dissipation downstream of the culvert. Additional considerations paid in the 17-mile tributary are as follows. The 17-mile house, located directly adjacent to the 17-mile tributary just downstream of Parker Road, as well as the property that the 17-mile house is situated upon, is identified as having historical value and is located within a designated conservation easement. As such, coordination with the conservation easement grantees is anticipated to be required in the future to obtain permits to perform this work. To reduce flood risk in the 17-mile tributary, Alternative 2, open channel conveyance capacity improvements is recommended. The recommended conveyance improvements include a high-functioning, low-maintenance process channel in combination with 8 2-foot grade control structures and one access road culvert designed to convey the 100-year event. The conveyance capacity improvements will increase public safety by reducing the 100-year floodplain inundation area within a historical parcel and will benefit the community by containing the 100-year floodplain with a reduced footprint. The recommended high-functioning, low-maintenance process channel will reduce the potential for upstream development-induced erosion within the reach, improving water quality conveyed downstream into Cherry Creek. Additionally, the recommended high-functioning, low-maintenance process channel will increase the environmental function of the reach by providing a more natural stream environment and reconnecting the channel to its natural plan and form.